So we'll get started shortly. I think it's, yes, 1:15. Thank you for coming. Did you enjoy your lunch? It's good, right? Really nice for them to arrange the lunch. If you're sitting on the back, please sit on the front. Why, you will understand later. So I want as many people in front as possible. This is you don't know Node. If you are in a different room, so this is the time to switch the rooms. I'm sure other presentations are good as well. This is the interactive session, so if you have your laptops, please open them. And how many of you use GitHub? Okay, so if you go to this URL on GitHub, you will find, first of all, the slides in the PDF and Markdown format. You will find the code folder, CODE, which will have the code examples for this presentation as well. And how many of you use NPM, which is a Node package manager? Okay, so you can also use NPM to get the same repository. So pull up your laptops and download the slides. Also, I will provide some resources. It's better if you click on the PDF. It will open the link in the browser rather than you typing. If you don't have it, just take a picture on your smartphone. So my big idea for this talk basically is to make everyone's lives better. So how is that possible? Well, JavaScript is the most popular language of the web. It's pretty much everywhere. It's on the mobile, it's on the browser. Now it's on the backend thanks to Node.js. It's getting into embedded systems and Internet of Things. So, and software is basically digitalizing our lives. It's eating up the world. It's changing. It's like a digital transformation. And by having more Node.js developers and Java developers, my goal is to help this transformation, this revolution, to help make the world a better place. So that's why I'm giving these talks. So I designed this presentation on purpose to be way larger than 45 minutes. Why? Because I want you to go download the slides and continue exploring on your own. And some of these concepts, they're really, really deep. So some of those concepts, they themselves could take 45 minutes easily if we go deep. So if you think like we're moving too fast, don't get discouraged. That's totally okay. What I want you to leave with is the basic understanding of some of the benefits of Node.js, and also, at least here, some of the core features. So there are 6 core features. At least by knowing what they're doing, you can later Google and search and continue your education and continuing your mastery of Node.js on those topics. Things like clusters, how to work with C++, etc., etc. So a little bit about myself. My name is Azat Mardan. You can find me on Twitter and probably more all of the major social media sites. My email is hi@azat.co if you have any Node questions. Currently, I work as a technology fellow at Capital One. It's a US and UK-based financial corporation. We're using Node.js, among other things like Java, and we're big on data science as well. My experience, I worked with corporations and startups, so I have exposure to different environments. I started as PHP developer, worked with Java as well. I've published and authored 11 books, most of them on JavaScript and Node.js. One of the popular ones is called Practical Node.js. You've probably seen it on Amazon.com. It's popular, but it's not my best book. My best book I consider ProExpress.js. And then the new books, React Quickly and Full Stack JavaScript, they're coming this year. So they're coming with free videos, so you can just go on YouTube, and Full Stack JavaScript is very good for beginners to Node.js. So If you go, you don't have to buy the books, by the way. I'm not promoting my books. If you Google them, I'm sure you will find them on torrents, right? So my goal is to, that's the reality, right? It's against my publisher's will, but that's the reality. My goal is to promote Node.js and basically have as many Node.js and JavaScript developers as possible, so you guys can benefit of open source libraries and other people can benefit too. Okay, so let's start with event loop and just the basic advantages of using Node.js. So how many of you are familiar with the non-blocking I/O and just the definition and what it's doing? Okay, so I've seen like 3 or 4 people, so I think we'll pause on this topic a little bit more and I'll really unpack it for you, because it's considered one of the major selling points when people choose to use or not to use Node.js versus some of the other frameworks and languages. So what is the non-blocking I/O? So obviously if it says non-blocking, there should be a blocking I/O, right? So think about a blocking I/O. If you go to a coffee shop and you have a cash register and you have one person taking money and taking orders, and the same person is going and making coffee or tea for you, right? So imagine in that cafe or coffee shop you have 20 people standing in line. So when it's your turn, you wait for your drink, but also the people behind you in the line, they're also waiting for your drink. And then basically each person after that person, they're also waiting, right? So the entire line is blocked by the first order, then the second order, the third order, right? So that's a blocking system, blocking input and output. And input and output, they're the most expensive typically tasks in our systems. So and then you might see a manager walks into this situation. You have 20 people standing in line. It's like, wow, this is crazy. People are leaving. They're frustrated. We need to scale this operation somehow. So the only way to scale a blocking input-output system is to add more cache registers, basically to add more threads. And that's how traditional systems works. In Java, Python, and Ruby, you would have multi-threading. So basically, you keep adding more people, and but in each thread, in each queue, they would be blocked, right? So Node.js solves this differently. It has non-blocking I/O. So that means one person who's taking the orders, they would not be the same person who is also making the orders. So the cashier would take your order and then they would yell to someone, similar to like a Starbucks. They would yell to someone like, hey, this is Fracca Mocha Latte, non-fat, cappuccino. And that person would be making, and you would sit at your coffee table and maybe watch some cat videos on YouTube, right? Way better than standing in line. So the top part is a snippet from Java. In this snippet, we're just putting the whole thread to sleep. And nothing would happen until 1 second has passed, right? In the Node.js example, functionally, it's doing the same. The step 3 would be outputted after 1 second. But the key difference here is that the process would not be blocked. So we can have some extra code executing. We can have this process do some other work while that second is passing, basically. And that's a key advantage of Node.js. It's not non-blocking I/O. It's not exclusive to Node.js. Other systems and platforms, they also have it. In Java, I think you have NIO, and in Python you have Twisted, which is a framework. In Ruby you have Event Machine. But in most of the cases, those are frameworks. And with frameworks, you have that complexity, because usually it's very hard in a multi-threaded environment to perform non-blocking I/O and asynchronous code, because you have to deal with concurrency, parallelism, you have to synchronize, worry about deadlocks and other conditions. Node.js by design, it's a single-threaded, so you don't have those complexities. It's very easy to start and get with the code. So any ideas about the order in which this will be executed? Unlike some traditional languages, this would be, so if we pretend like This is a traditional language. If it's a blocking I/O, so we might think that step 1, then step 3, then step 2 would be executed, right? But what is actually happening, set timeout, it's scheduling this event in the future by using callbacks. And event loop is the mechanism by which it works. If we go to the previous slide. So event loop is single-threaded. It's scheduling some I/O events here. We have file systems, we have databases, we have computation. So very expensive stuff is happening somewhere in the background. It's not happening in the Node.js itself. Oops. And then if we have step 4, this would be executed after step 2, and only after step 4, step 3 would be executed, and then step 5. This is another illustration. So we have 4 clients. Maybe it's a browser, maybe it's another application, and they're submitting requests. So the client at the bottom, he or she submit 3 requests, and each request from that client ends up on one thread, and that request has to wait for the previous request to finish. When we have non-blocking I/O, basically event loop schedules those events, delegates them, and there is no waiting. Event loop is handling that. Now, it's still possible to write blocking code in Node.js. So a basic example would be something like that. So we have a for loop, and it's spinning, and I tested it on my computer. It took about 500 milliseconds. So obviously, in real life, you're not going to write loops like this, or it's very easy to spot loops like this. If you write real code, you don't want to write blocking code. But sometimes you're using modules that provided to you by someone else, right? This is a FS, it's a file system module, and it has 2 sets of methods. One set of methods is asynchronous methods, and the way you know, they have sync in their names. So read file sync, it's a method to read the data from the file, and you would also have write file sync if you would write. So what is happening here, we get the content, and then we output the content, and then we would say hello Ruby. And then same thing happens with the hello Node. So basically each line goes one by one. The line when we're reading the content from the file, it's blocking everything, so nothing would happen until we read the file. And we can save that into a variable. Now this is a non-blocking code, and it's asynchronous code. We're using callbacks. And in the callback, we have this variable content. So what would happen, first we would see hello Python and hello Node. We would not see content. And then after some time, we would see the output of accounts and then output of ips.txt. A little bit about conventions. So usually we have error as the first argument in our callback. And then we have the data or the result. And then the callback itself, it's usually the last argument, last parameter of whatever method we're using. And keep in mind, this is just a convention. It's not enforced by the framework or the platform. If you write any other way, it's going to work, but your coworkers and the developers who consume your library would hate you, most likely. So keep that in mind. Okay, so let's talk about global and process. How many of you are familiar with window and document in the browser JavaScript? Okay, so we use those for exporting modules, but there is no window in Node because it basically doesn't make sense. It's not a browser window, right? So other use cases, for example, how to store a password in a Node.js application, right? Because we don't want to hard code it in the code. We don't want to push it to GitHub. We need to store it somewhere. And also, maybe we want to pass some parameters, like a command line interface parameters, or access some information about our platform, our environment, because we can do that. We're on the backend. It's Node.js. It's not browser JavaScript. We have this global object. It's called global. And it's a lowercase or capital case. They are aliases. And then inside of that global object, we would have process, which will give us process information, and then we would have a few more properties. So file name would give you the path to that script that you're currently running, and the dir name would give you just the directory name or the folder name, the absolute path to the script that you're running. Module and require, those are methods and objects for modules, Node modules. Node uses CommonJS, which started as a browser standard, but now Node.js adopted it for the backend. And basically the way it works, you would assign whatever object or functions you want to a module, and then you would use require to import that. Speaking about process, these are some of the properties on the process object. We can get the process ID, the versions number, architecture, argv, that's the command line arguments, and then process.env, that's environment variables. So things like API keys, passwords, we get in that from process.env. It's also very useful to get some statistics, for example, like memory usage, uptime for monitoring purposes, and then we can exit the current process with process.exit, and we can also attach some events. Okay, so who really likes callbacks and understand them in the browser JavaScript? Okay, a few people. Callbacks are good, but most people, they tend to don't like this thing, which is called callback hell, or pyramid of dumb, or nested approach. So basically what ends up happening, because you need to write asynchronous code, and you use callbacks to schedule that functionality in the future, you end up with a lot of indentation, and this code is very hard to read, it's very hard to understand, hard to maintain. Code is a liability, it's not an asset, right? To solve this problem, we have event emitters, which is Node.js implementation for observer pattern. It's an implementation for observer pattern. And it solves this problem, how to modularize and basically work and organize your asynchronous code nicely. So the official documentation for event emitters, if you follow that link, the idea, how many of you are familiar with observer pattern? Okay, most of you, that's good. So this will be easy topic. Since you're already familiar with what observer and why it's good, this is the Node.js implementation. So we have events, and require, that's how we require a module. As I've already mentioned, events, it's a core module. So we don't need to install it with NPM, we don't need to do anything extra, it's already part of the system, part of the platform. And what we need to do, we need to instantiate that object and save it into emitter. And that's pretty much it. Now we're ready to attach some event listeners. And knock, it's just some custom event I came up with. It could be anything. So basically it's just a string, that's the name of the event. And then we have the callback. So the idea is here that you're telling, okay, so when this event happens, go ahead and execute this callback. Go ahead and execute that logic. And then the way we trigger the events, we invoke emit. So emit will send the signal that some event has happened, and then event emitter will catch that event. So in this case, it will output who is there, go away. It will output basically once. Let me do a quick demo. Can you see? Okay. So I have it twice because what I did, I actually triggered it second time. So, and I can trigger it multiple times. And the order in which they would be executed is the order basically, in which you define them. So let me flip them and see what happens. So now it says go away who's there, right? So that's all very trivial. We can make it a little bit more interesting, because it's not really interesting to just have an event emitter and it doesn't do anything. So in this example, we have, let's say it's an emailing job. So we need to send some emails, and we have 3 types of different emailing jobs. One is daily, one is weekly, and one is monthly. Okay, and this is the class that implements all 3 of them. Basically, it's generic enough that it will work for all 3 of them. Maybe we can pass some parameters here to basically tell, okay, execute weekly or daily, etc. But what we need to do, we need to execute some logic at the end of this job. So when the job is over, we need to say, hey, it's weekly or it's monthly, it's done, and this is the time. So we get the new date. So this is the module, it's job.js, and we export this module. And this is the main file for the weekly task that requires the module, and then we attach this event listener. So basically we're telling, hey, when the job is done, go ahead and do some custom logic. So the custom logic does not live in the module. All module is doing, it's emitting the event, and then it's our choice. We can have 1 event listener, we can have 2 event listeners, or we can have 0 event listeners, right? So that's the flexibility. And then I'm also removing all event listeners at the end. We can have more. So this is some of the methods that provides more flexibility compared to callbacks, right? We can implement something similar with callbacks, but it's going to be really messy. So that's why event emitters are nice. Once it will execute the event listener, the callback just once. Remove listeners, it will remove everything, and listeners, it will list the listeners attached to that event. Do you want me to demo it, or it's pretty much straightforward? Okay, so we're gonna skip it. Streams and buffers. So streams is a pretty cool concept. I just was downstairs at a presentation about streams and Java and stream analytics. I think it's really, really good. So the problems is that we have the buffer limitation, 1 gigabyte basically. If you're trying to read from a file which is larger than 1 gigabyte, and your buffer will be basically full. So if you try to read from that file and transform the file and save that file, it's not going to work. So when you're working with large files, you need to use streams, and then also the speed. If you have a lot of large files and you're reading them, basically you're waiting for them to load, and then you transforming them, and then you're writing them. That's too much time, right? The better idea would be to use streaming, which is, what is streaming actually, right? It's this abstraction of chunking. So the idea of chunking, that we can start processing the data right away. We don't have to wait for the whole data to finish. Okay? So instead of waiting for the whole 1 gigabyte, once we get the first bytes, we start processing it. I think it may be my clicker. So let me turn it off. So there is no need to wait for the entire resource, entire file, or the request to load. So there are 4 main types of streams. We can have a readable stream, writable. So readable means we can consume it, we can read it. Writable means we can output to that stream. And duplex, it means it's both readable and writable. And the transformational, it means we can do some work, can transform it. And streams also inherit from event emitters. So remember that job object, it inherited from event emitters, so streams also inherit from event emitters. So one concept builds on top of another. So streams are everywhere in Node.js. You don't have to use them, but if you have those problems, you can use them for HTTP requests and responses. You can use them for standard input-output. You can read from files and write from files. So this is how you would access standard input. So basically you have a Node script and you can pipe some data in your command line. That would be standard input. And this is a basic example. So process.stdin.onData. So again, similar syntax to event emitters. And then we have event on end. So on end would be when everything is done, when the whole stream is finished, and then the chunks we get the byte by byte basically data. So we can start processing it right away. Okay. Streams has also a different interface where we would use readable.read. It's a synchronous function, but it will give us the chunk. And then we can basically have a while loop. While it's true, we will keep getting chunks, and when we can do something with those chunks, transform them maybe. Process.stdout, that's the standard output. It's usually when we write back something to the console, that's what we're using under the hood. Process.stdout.write, that would be similar to console.log. So what about HTTP? So this is an HTTP example, and I'm using ES6 on this. How many of you use ES6? Oh, okay, really good. So what's happening here, we have REST, it's a response, and REC, it's a request. So when request is coming, so this is a server, so request would be some client submitting data. We have this on data event listener, and when we're having chunks, we basically keep adding them to the body. And when the request is done, it's finished, we have the body, and we can parse it, JSON.parse, and we finish the response, response.end. So if we want to do, if it's a large incoming request, if we want to do something, we would put it here on in the request.onData. We can also use pipe, which is just another way of using streams. So in this example, we are creating a read stream from a file, and then we apply in gzip. It's a transformational stream, and then we write to the file. So this way we don't have to actually store anything in the buffer. We're just streaming from reading, and then we're transforming, and then we finishing by writing that stream. Okay, so there is this data type which we don't have in browser JavaScript. It's called buffer. So it's a data type for the binary data. This is how it looks. It looks like an array of some numbers and digits, and then we can use toString to convert it to a string by specifying an encoding. Okay, so remember the file system module? This is how we can read from a file using callbacks, but the data, it's actually a buffer, it's not a string. So we need to do something extra, like apply a toString method to it. So buffer are really cool. By default, everything is a buffer when you're working with file system, when you're working with requests. And here are the encodings available. Okay, so in this example, I have an Express server. Express, it's a Node.js framework, one of the most popular Node.js frameworks. And I have, let me show you the code. So this is how the server looks like. I have two sets of endpoints. I have non-stream and I have stream endpoints. And they're pairs because I'm just using different style, but they're pretty much the same. So in non-stream, I would be using synchronous method. And in non-stream 2, I would be using asynchronous method, but they are not streams. And obviously in /stream and /stream2, I'll be using streams. One with event listeners, another with pipe. So pretty much the same thing, just different styles. The idea here is that we have streaming and non-streaming. So let me go to my terminal And the file name is service stream if you're following on your computers. So I've started it. And now I'm going to, let's first go to non-stream. And I have a huge image, like 8 megabyte image that I'm loading. And I'm going to networking tab. Let me disable cache. And if you can see, the response time is it's 6 seconds. Six milliseconds. Okay. So now I go to the streams. Ideally, I should expect to have lower response time. Yeah, now I have 2 milliseconds. So almost by 3 times less response time. So the same image, but the response time is less because I start to stream the image faster, right? I don't have to wait for the entire image to finish loading. Yeah, X response time in your DevTools. Some of the resources to continue your education with streams is Stream Adventure and Stream Handbook. It's an interactive workshop that you can read the instructions to the exercises, to the problems. You can solve those, and then the tool itself will verify your solutions. Okay, so some people, they get a little bit concerned that Node.js, it's a single-threaded, right? Because if you come in from Java world and it's multi-threaded, you think that it's somehow better for scaling. So with clusters, you can scale your single-threaded node process, and you can scale it vertically, basically, by having multiple workers. So you would have one master, and master would fork workers. So if you have 4 CPUs on the machine, usually we have 1 master and 3 worker. And the worker, usually it's your server. So the actual code that doing the actual job, it's a worker. And then the master, it's a process that monitors. For example, if a worker dies, so it crashes, it will restart another worker again. And as you can see, it's only a few lines of code. All we need to do is check cluster.isMaster or cluster is worker, and that's it. So the one file stores both for masters, and maybe I should turn off the mic. Just think it's annoying for people. Hello, 1 1 1 2 3. Okay, so. And you don't have to have the same number of processes as number of CPUs. You can have more, but then the law of diminishing returns basically kicks in. So usually we have the same number of processes as the number of CPUs. So with clusters, you can very easily utilize the maximum CPU power from each machine. So I have this small demo of a cluster code. Don't get scared because of I have too many lines of code here. Most of them, they're just console.logs for outputting. So what I want to do, I want to output individual process IDs. So we can see that actually different process IDs respond to our different requests. And I have Express. I'm using Express.js as a server. Okay. Sorry for the noise. Okay, so it's similar to load balancing, but it's not actually a load balancing because it's not going to distribute evenly. If you want to use load balancing, there are better libraries like PM2. It's a really good choice. It has the load balancing, and it's also provides you more features in addition to just using cluster. So cluster, it's a low level. The only advantage of cluster is that you don't need extra modules. It's a part of the platform. With PM2 and strong cluster control, you get a lot of features. It's a production ready. So when you deploy to production, use PM2 or any similar libraries like that. I can quickly demo you how PM2 works. So PM2 space start, and then server.js, the name of my application. So basically, it even has like a nice command line tables that shows you what processes are running, and then it goes to the foreground. It goes to the background, so you get back to the command line terminal. And then if you want to see, okay, so what processes are running, it shows me, okay, I have one server and just one PID. So if I want to scale it, I need to, so by default it's just one, but you can have more because that's the whole purpose, to scale it up. And yeah, some of the advantages of PM2. Demo, we just did it, so you can also run the same load test on the same port and localhost to stress test it. Okay, so I just killed all the processes. I'm starting it again. So now I have 4 processes running, and let me repeat my experiment. So the parameters -t20, it's a timeout. So 20 seconds is the timeout when the load testing tool will stop working on this job, basically. And then -c, it's a concurrency. So we have 10 concurrent requests hitting the server at the same time. And I'm going to PM2 list. So they're all still online. And if I compare the numbers, technically I should get better numbers with PM2. So it says 89, 98, and here I have 110. Requests per second, 800 requests. Okay, thank you. Okay, so I guess the last topic that we will be covering during this presentation, but there are more information in this slide, so I encourage you to continue exploring. It's how you would start a process from within Node.js, right? So Node.js, it's a backend on the server, on the browser JavaScript. We cannot start any processes, right? Because it's just a browser. In Node.js, we have 3 ways to start a new process. Basically, we have spawn, which is it's very versatile, very flexible. You can use it with any process. You can launch Java, Python, Ruby, anything you want, Bash script, and it has streams, so it's good for large data. Exec on the other hand, it has a limited buffer, but it's a little bit compact interface, so it's a little bit less code to write. Usually I use it for like a small command lines, or if I need to run some shell command, I would use exec. And then the fork, it's only for Node.js processes, so you've seen fork and clusters. That's how we created multiple workers. And then I'll just If you're interested in how we use Capital One at Node.js, this is the talk I did in December. It's on YouTube. The interesting thing with Capital One is that as a financial institution, we have some regulations. So if you working in a heavily regulated scenario, let's talk and share how we do it. Okay, so 30-second summary. Event emitters, they're observer pattern, right? It's a little bit better than callbacks. And streams, large data, more performant than just waiting for the entire resource to load. Buffer, it's a special type, special data type. And then clusters, that's how we scale vertically. We didn't talk about C++ add-ons, but that's one of the reasons why Node.js is so popular in Internet of Things, in hardware, in robotics, in node captors, etc., in drones. Because once you have hardware, which is usually C and C++, it's a good start. But then you want more developers to develop for your hardware. You want to have a good, nice SDK, right? And developers usually they're not as proficient in C, C++ because those are low-level languages, right? You need to do a lot of manual things. They're more proficient in JavaScript, which is a higher-level language. So those hardware manufacturers, they develop Node.js and JavaScript SDKs usually. And it's very easy to write a C++ add-on with Node.js. And then domain, it's one of the approaches how you would handle asynchronous errors. Because when you're working with asynchronous code, you need to shift your thinking, especially if you're coming from Java world and it's mostly synchronous code. So that's one of the major, when I'm teaching Node.js courses, I see Java developers, I think that's the hardest thing for them to basically start thinking in this asynchronous thing, and then the debugging and error handling, it could be challenging. Okay, so questions? No questions? Yes, promises, it's, so the question is when would you use promises, right? Yeah. Yeah, so the question is if it's better to use promises than some of the things that we talk about or not. Up until ES6, promises, they weren't part of the language itself, so you would have 5 or 6 different implementation of promises. So first, like picking between what library to use, it was hard, right? You would argue about that. And then the interface for promises would differ depending on what libraries you use. So now we have ES6. So, okay, it's better, we have standard. We have one library that is in the part of the language, right? And the ES6, you don't need anything extra. By default, it's in Node.js 5 and 4. So my personal take, I prefer callbacks and event emitters. They're everywhere, so you just have to use those, right? Callbacks, I don't see, just personally, I don't see, and of course my opinion is very biased, I don't see that much of a benefit. Just from the code, looking at the code, it's not much verbose. You have to use then, dot then, dot then. So I don't see that many benefits. But async await, it's a nice abstraction over promises. I'm really looking forward to async await. I think it's an interesting thing. And then generators is another way to also write asynchronous code. What else? So we have promises, generators, async await. There is also a library called async and neo-async. So they will require you to install them via npm. So that's the only disadvantage, but with them you can run concurrent functions and do other nice things to organize your code. Do you have a question? Yes, that's right. So the question is how to handle errors with when you're using streams. I think that's a trade-off you have to make. if you're doing some financial transaction and it's important that you basically monitor everything from end to finish and you absolutely need to guarantee that it's been done without errors, then maybe streams are not the best implementation. If you don't really worry, like you're streaming a movie or you're watching on Netflix, something like that, right? So don't really worry if you crash it, and the client will resume the operation. So, but then in the code, I'm sure there are ways to also do it in the code. Last question? No? Okay, that means I did an amazing job. So don't have questions. Before you leave for the next talk, this is the short book I wrote based on the ProExpress, which probably the best book on Express.js framework. And yeah, it's free, first come, first serve. Enjoy.